Hello, 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 and welcome everybody to math. Welcome back. Happy Monday. Hope you had a great weekend. So on and so forth. Mixed number multiplication today. Sounds daunting. It's not, I promise. It's pretty straightforward, and it's nothing you haven't done before. We'll go over it today. Things you need, something to write on, something to write with. The usuals to practice. Just a reminder, when you're watching these videos, please have something to write on and something to write with. It's a lot harder, it's a lot more challenging to develop new math concepts using mental math strategies. Okay, mental math is another piece of practice. It's not the only practice. So if you're not writing things down while you watch these lessons, it's more challenging to pick up these lessons, and I can tell on your exit tickets. And here's our I cans today. I can define multiplication as repeated addition of a given value. I can multiply a mixed number by a whole number. Let's get started today. And before we get into mixed number multiplication, I want to go over this thing up here, the distributive property of multiplication. All these properties, all these rules. Really, this is nothing you haven't done before. Essentially, what the distributive property of multiplication means is if you have a multiplication expression, you can take one, either really, of your addends and of your factors and break them up into addends. So taking this 12, and the easiest way to start, I would say, is by using expanded form. So we could say 3 times, instead of 12, we're going to say 10 plus 2. Okay? And then the distributive property of multiplication says kind of drawing there, is multiplying each addend by the other factor will get you the same product as multiplying the whole thing. So essentially saying that 3 times 10 plus 3 times 2 equals 3 times 12, or 3 times 10 plus 2. Okay? And we do this already when we use area model, right? If we were to write this out as an area model, we're doing exactly that. We're saying this is a height of 3, and then we're breaking up our length into 10 and 2. 3 times 10, and 3 times 2. And then we add those partial products together at the end. We've really been doing this the whole time, but we haven't done as much naming of it. We haven't done as much naming of it as the, it's up there on the title, as the distributive property of multiplication. Okay, so I just wanted to make sure to name that as we go. Because when we're dealing with mixed numbers, which a mixed number being a whole number plus a fraction, using this distributive property and using an area model comes in handy. So let's say we have something like, instead of 3 times 12, maybe we have something like 3 times 2 and 1/3. No, we'll use 2 and 1/4. I want a mixed number answer here. Okay, so 3 times 2 and 1/4. Okay, and using that distributive property knowledge, using that partial product knowledge, we can rewrite this expression as 3 times 2 plus 1/4. Because that's essentially what a mixed number is, right? It's a whole number plus a fraction. Then we can multiply both of our terms, both of our addends, by 3. Essentially going 3 times 2 plus 3 times 1/4. Okay? 3 times 2 is 6. Keep our plus sign. And then 3 times 1/4, or 1/4 plus 1/4 plus 1/4. How many fourths do we have? We have 3 of them. So 6 plus 3/4 equals 6 3/4. Okay, so by using this distributive property and thinking about breaking our mixed number up into multiply it by the whole number, and then multiply it by the fraction. Multiply our first factor here by the whole number, then multiply it by the fraction, add those two partial products together. In an area model, it would look something like this. We have 3 on one side. I know it's not to scale. This should be longer technically, but for area model, it's not to scale. We're just using it as a tool. And then we have 2 plus 1/4. So now we have a rectangle that is 3 by 2. And we have a rectangle that is 3 by 1/4. Add those two partial products together, and again, you get 6 3/4. Let's go to the digital whiteboard and try a couple. There we are. Hello. Okay, first one. Let's try it. I'll give you a minute to try it on your own. We're going to try 8. Whoops, I need a pen. 8 times 2 1/3. 8 times 2 1/3. Try it on your own. And what do you notice? Okay. If you end up with an improper fraction, what could you do? Spoiler alert, you're going to end up with an improper fraction. So what do you need to do? Okay, so start by separating out your 2 1/3 into 2 plus 1/3 if you're using an area model. All right, draw your box. Eight on the side, put your whole number on the side, and then 2 plus 1/3. So you end up with 2 partial products here. Or separate it out and go 8 times 2 plus 8 times 1/3. Okay, both answers, or both methods, are acceptable here. Okay, we're seeing a couple of answers in the chat already. Let's go a little further and think about what those two partial products would be. So 8 times 2 is 16. And then 8 times 1/3, right? Exactly. Multiply your numerators. 8 times 1 is 8, because you're going to have 8 of them. And the size of each piece is 1/3. So you end up with 8/3. Now, you could just write it as 16 8/3. That would be, an accurate answer, but let's get rid of that improper fraction if we can, okay? And I happen to think it's easier to do it before adding your partial products together. Some people like doing it at the end. So I'm going to take 8/3 and think about, okay, if I have 8 items and I'm making groups of 3, because 3/3 equals 1. How many groups of 3 can I make? And then how many are left over? So here's I'm going to just do little tally marks for each of my thirds. I have 8 of them. I'm going to make groups of 3. 1, 2, and then we have 2/3 left over. So we end up with 8/3 is equivalent to 2 2/3, because we can make 2 whole groups with 2/3 left over. Okay. Then we can add 16 plus 2 plus 2/3 to give us our final product of 18 2/3. Makes sense. I'm seeing that in the chat from a couple of people. Good. Let's try another one. Let's go with the green pen for this one. Let's try 4 7/10 times 8. Stick with the 8 here. Now, you will notice I put the mixed number. Did I put the mixed number first on this last one? No. I put the mixed number first on this one. Does that change how you set up your area model? No, it doesn't have to, right? We've also got that commutative property. You can switch the factors and the product stays the same, right? 4 7/10 times 8 is the same as 8 times 4 7/10. So that doesn't change how you set up your area model. It can still be whole number on the side and mixed number on top. Then find your partial products. Okay. Seeing different answers in the chat, which is great. I like a disagreement here. So let's think about our partial products here. Right, we've got 4 times 8, and then we've got 7/10 times 8. Okay, 4 times 8. Consult your multiplication chart if you need to. Zoop, zoop. I see 32, where 4 and 8 meet. And then 7/10 times 8, remember, multiply your numerator by the whole number, because that's how many tenths you have. So that's what you're multiplying. That's the group. So 7 times 8, I consult my multiplication chart, is 56. And then the size of the piece stays the same. So we have 56 tenths. We're just doing repeated addition of those tenths. So we stay in tenths the whole time. Okay, so 32 and 56 tenths would be an accurate answer, right? But let's take our 56 tenths and think about, okay, how many groups of 10 tenths can I make with 56? So tell you what I'm going to do for this, because I don't really want to draw out 56 tally marks. I'm going to count by 10 and keep track of how many 10s I can count to until I can't go anymore, right? So we've got 10, 20, 30, 40, 50, and remember my number is 56, so I can't go past there. So I know I've got 5 wholes, 5 groups of 10 tenths I can make. And then how many left over? Because I used 10, 20, 30, 40, 50. So 56 minus those 50 with 6 tenths left over. So I end up with 5, because here are my whole groups of 10 tenths, with 6 tenths left over. 6 tenths is my remainder. So now I'm going to add 32 plus 5 and 6 tenths equals 37, 32 plus 5, and 6 tenths. Okay, and I saw somebody in the chat reducing that 6 tenths down to 3/5. How come that works? I agree that it does work, but how come? Why are 6/10 and 3/5 equivalent fractions? So remember, when you're reducing fractions, if you see something like 6/10, I'm writing it up here at the top. If you see something like 6/10, my key to can I reduce this and make a fraction with a larger denominator, a smaller digit but a bigger piece. My first clue is, are both of these numbers even? So can I divide them both by 2? And I can, right? 6 divided by 2 equals 3. And 10 divided by 2 equals 5. In essence, what I'm doing here is dividing by 2 halves, or dividing by 1, which doesn't change the value. Just like multiplying by 1, dividing by 1 doesn't change the value. Okay? If I can't divide by an equivalent of 1, then I am as reduced as I can get. Okay? Let me check the chat, see how we're doing here. Yep, we've got divide both the top and the bottom number, both the numerator and the denominator, by 2. Exactly, to get us a final answer of 37 and 3/5. All right. Thank you, everybody, for tuning in. We'll keep this one brief because I do want to see how you do on the exit ticket. Remember, really, it's as straightforward as breaking up our whole number and our fraction and then multiplying each one by our other factor, adding those two partial products together. All right, go ahead and give the exit ticket a try on your own. Office hours will be open at 11 o'clock if you have questions or you would like some extra problems. Remember also, if you want to practice some other concept that we've learned this year, right? Maybe you got to the reducing fractions part of that last practice problem and went, wait, I don't remember how to do these, right? Come to office hour and let's talk through reducing fractions, right? I am confident that if you show up to get what you need, you will end up a better mathematician for it. All right. Thank you, everybody, for your hard work. I appreciate all of you. Hopefully, I will see you in office hour in about 10 minutes. If not, have a good rest of the late morning and a good lunch and a good PE, and I will see you on Zoom for journalism at 1:15. Cheers.